Hey everyone, so for our video notes today, I'm going to try to cap them at a certain amount of time. But what we're going to do is recreate a cheat sheet that we've made in the past. So you might already have it and you could just add on to it if you want. I didn't bring all my stuff home when we went fully remote, so that's why I'm doing this and I'm making a new one. So we're going to be calling this our factoring cheat sheet. And we've done factoring in our other chapters, and it's going to keep happening all through second semester. So here's a review of factoring. The first step when you factor is you always want to look for a GCF, a greatest common factor. What can you factor out of each term? So remember, in order to factor, it does have to be in standard form, and that means it's the highest exponent, then the next, then the next, then the next, until you get to just the number, okay? And a GCF is you're looking for that common number or that common variable that you can factor out of each term. And the term is just those pieces separated by the addition and subtraction signs. So in the past, we made a branch and we had 2 terms. And then I made a branch and I called it 3 terms. And that's what we've done so far. But today, what we're going to do is also add 4 terms. So the 2 terms actually has an official name. It's called the difference of squares. And so the example that I want to use here is just this 4x squared minus 81, for instance. So remember, it gets the name difference of squares because the subtraction is the difference, and the squares is because each term has a nice square root. And if you take the square root of 4x squared, you get 2x. And if you take the square root of 81, you get 9. And then you can go straight to your factors or your neighbors, and one of them becomes 2x plus 9, and the other one becomes 2x minus 9. And it doesn't matter if you do the minus and then the plus, but this is the final factored results. Now, if you have 3 terms, then this is an example of something that would be 3 terms. Let's see. In the 3 terms, what we do is we make our x. And we complete the x by multiplying these, and that gives me negative 24x squared. And then this middle term just goes what's on the bottom. And then you could use that factor page that I gave you. I believe it was green, or your factor program. But I would want to know which factors of 24 get me to 5. And if you notice these x's that I've put in there, looking at past work, some of you leave those x's out. You can't leave those x's out. You need them in here because we're going to be factoring with higher power, so it's really important that we include those x's. So factors of 24 that get me to 5 are 8 and 3. And since this is a negative 5, I would want to make sure that that negative 8 is there. So when I multiply these, I get the negative 24x squared, but when I add these, I get this. And then what you can do is you can go straight to your factors or your neighbors, and we'll ask which neighbor met which neighbor to make this 2x squared. And it's going to be pretty basic, no fractions or anything. That would just be 2x and x. And then what I like to do is draw a loop from 2x to the other parentheses for that neighbor, and draw a loop from x to this spot for that neighbor. And I'm going to bring all my focus back to these side numbers. And for instance, I could ask myself, can I take 2x times something to get to this? And I could. I could take 2x times negative 4 and make that. And that would give me, just as a reminder, the negative 8x. And then I would use this one to answer this question. Can I take x times something to get to 3x? And that would be a positive 3. So that was factoring with 3 terms. Now remember, not everything's factorable, and we'll worry about that later. What we're going to work with right now are things that are factorable. So now with 4 terms, here is the example we're going to look at. So let's make it. Now, in this first example that we're going to do together, this is the only one that will incorporate a GCF. So this didn't have a GCF, this didn't have a GCF. I knew it didn't have a GCF, I didn't bother with it. But let's look at this one. This one does have a GCF. So not all of them have an x in there, so I won't be able to factor out an x, but all of these numbers can be divided by 2. So what I'm going to do is quickly factor out or divide out that 2, so I get x cubed, divide this by 2, and divide that by 2, and that by 2. And now what we're going to do is just focus on what I'm underlining here. These are the 4 terms. 1 term, 2nd term, 3rd term, 4th term. And what I'm going to do is, just for sake of showing work, is just rewrite it down here. And this is how you factor 4 terms. What we're going to do is we're going to group them. We're going to group the first 2 in parentheses, and we're going to group the last 2 in parentheses. And I want to make sure that I include that minus in with this 4x. And now what I'm going to do is actually go back to this GCF piece. What I'm going to ask myself is, what is the GCF? What can I factor out of both of these? Now I can't factor out a number that's called a coefficient, the number that's in front of the variable, but I can factor out an x. This has 3 x's, this one has 2 x's, so I can factor out 2 x's from each term. And now we're just back to neighbors meeting neighbors. Who did x squared meet to get to x cubed? And that would be x. And who did x squared meet to get to 5x squared? That would be 5. Now once you get the first one done, the second one is a lot easier, because what's going to happen is that when you do the GCF here, whatever's in the parentheses for this set will match what's in the parentheses for this set. And that's going to force you to take a certain number out. So what I would want to know is, who is the neighbor hanging out here that met x to get to negative 4x, or who's the neighbor out here that met the minus 5 to get to 20? And that would be a negative 4. So I'm going to write the word match here. So remember, these have to match. But I'm also now going to draw a bracket here. And now you actually have your factors, or your neighbors. One of them are the things that will be on the outside. So x squared minus 4 will become one neighbor, or one factor. And the matching set will become the other neighbor. So when this neighbor multiplies into this neighbor, you do get back to this step. And then when this neighbor multiplies back in, you get to this. So a couple things. So first, my factors are not all the way listed. I would want to remember that there's still a 2. And every time you think you're done factoring, the one you always need to watch out for is difference of squares. So we think we might be done, but as it turns out, this is a difference of squares. This has a square root of x, this has a square root of 2. And so if I'm going to factoring it completely, which is what the directions will say, I'll bring the 2 down, and then this can become x plus 2 and x minus 2, and then the x minus 5. So there's actually a lot of factors, or a lot of neighbors, that came out of this one. But the whole idea of factoring 4 terms is this grouping piece that we called grouping the first and the last set. And those are the first round of notes. So let's see what time we're at so far. All right, so now I'm in the packet. I'm in the white packet. Or I'm sorry. I don't want to be in the white packet. Hold on. I want to be in the pink packet. Okay, so I'm in the pink packet right now, and I am on page 56. And we're going to walk through some of this together. But what I want to point out is that that little table, that cheat sheet that we just made, is what would be here. But I'd rather us have it on a separate piece of paper, so if we want quick access to it, we would have that. Now when we get back together in class, we can 3-hole punch this and put it in our binder. Okay, so we've already covered this part, but now what I'm going to do is come up to the top part. And the other thing I'm going to ask that you have is your graphing calculator. Now if you don't have your graphing calculator, you could also use Desmos. Right now the sun is pretty bright in here, so I'm going to get the other graphing calculator. Maybe that will show it better. Yeah, that one shows up a little bit better. So I don't know if I can make it any darker. Hold on. Ooh. Okay. Well, maybe this one will show up now. I should have tested this first. Okay, now I got that. Okay. So anyway, again, I'm on page 54 in the pink, or sorry, 56 in the pink packet. So let's just review a little bit more with the factoring practice, and then also what finding the zeros means as far as the graphing calculator goes. So we're going to factor this, and we're going to find the zeros. So what I noticed first is that there are 3 terms. So going back to my cheat sheet, what I would want to try is for a GCF and then go into my x. So what I notice is there's not a greatest common factor. So I'm just going to go straight into my x. And I'm going to ask myself, okay, are there factors of negative 70 that get me to this negative 3? And I'm not saying the x, but I'm thinking about the x. And again, you can use your factor program, you can look at your factor page, but I will end up with 10 and 7. And in order to get a negative 3x, I want to make that 10 negative. So then I can go to my factors, or my neighbors, and again, the neighbor or the factor that we always go for is this one. What times what, or who met who, to get x squared, and that's just an x and an x. And then again, from there, I would draw a little loop like this, and I draw my focus to the sides. And I ask myself, can I take x times something to get to negative 10x? And I can. That's negative 10. So that gives me my little negative 10x. And that means I'll use x times this spot to get to 7x, which would be a positive 7. So that's factoring. Now finding the zeros, if you recall, means we always set our equation equal to 0. So it would turn into something like this. And we've already factored, so I'm just going to bring this step back. And finding the zeros now means I'm going to set each factor equal to 0, and I'm going to solve. So set that factor equal to 0, set that factor equal to 0. And most of you probably don't have to do that. You can just see what it would be, but sometimes it's not as simple. So my zeros are negative 7 and positive 10. Now what that means for the calculator, what I would do is, because we've got this box here, is I would be on the y equals. Now based on what we did last time, you might have this plot one on. So you want to go and if it's on, hit enter and shut it off. And I'm just going to type this in, x squared minus 3x minus 70. And again, the first time I always graph, I always do zoom 6 for a standard window. Okay, so this is pretty wide. So what I want to do is definitely go more to the right. But what finding the zeros means is you actually know where it's crossing the x-axis. So this is actually your negative 7, right? And over here is your positive 10. So as you switch your window, you can do your x min to negative 10, which is fine, but maybe I'll do the x max and go up to 15 because I know it's going to, at least I need to get past 10. Now the other thing you notice is that it wasn't far down enough. And so one thing I want you to keep in mind is this is the y-intercept. A y-intercept is when the x is always 0. And so if I were to go in and make these x's 0, 0 squared is 0, 3 times 0 is 0, so 0 minus 70. So again, what I'm saying, if x was 0, my y value would be negative 70. I know that this is crossing way down here at negative 70. So what I'm going to do is go back to my window, and when I go to my y min, maybe I'll try negative 100. Definitely go below that y-intercept, and let's see what happens. And now I've got the full shape. So some different things, and I can always help you adjust that window, or Desmos is great, again, because you can just use your fingers and zoom in and out with the touch screen. But here comes the shape. So again, just what finding the zeros means is we have found one x-intercept of negative 7, 0. We found another x-intercept of 10, 0. And just a little on the side note, you actually, without even having to do any math, knew the y-intercept. So when it's in standard form, it is just the number that's at the very end. And again, the reason why that happened is because all y-intercepts have an x being 0. And when you put 0 in for x, it basically wipes out this term and this term, so you're just left with that. Okay? All right, so just looking at the rest of this, solving, so finding the zeros is essentially the same as solving. You would basically just factor this down. Let's go back to what they were. And then you would set each factor equal to 0 and solve. So what might be the difference if these look so different is that zeros, you have to put the 0 in. In solving, it's going to equal some number. And so in this case, it's equaling 0. And then you would go about solving it. And then when you find the x-intercepts, finding the x-intercepts is where you are just finding where it crosses the x-axis. Okay? So all these things are very similar in what they're asking, but they're all presenting themselves a little bit differently. Sorry, I'm just trying to figure out how much time we got on this video. So 1 second. Oh boy, I don't know where my video is now. Here we go. I lost the recording button. I'll be editing this down here in just a moment.